Swapping nodes in a linked list. You are given the head of a linked list and an integer k. Return the head of the linked list after swapping the values of the kth node from the beginning and the kth node from the end. The list is one indexed. Okay, so given an example 1, given the linked list going from 1 to 5, if k is equal to 2, then we want to get the node, the second node from the left and then the second node from the right and swap them, right? So here in this example, the second node from the left is 2, and then the second node from the right is the 4. So we pretty much just swap the 2 and the 4, and you'll see that, or like we're swapping the values of those nodes, and now we have 1, 4, 3, 2, 5. So like a pretty good way to solve this is using 2 pointers. So what you could do is, okay, so basically in a linked list, you don't want to try and get like the length of the linked list. Anytime a problem gets to a point where it's like, oh, I need the length, and I need like, because like basically here, right, to get the kth node from the left side, you pretty much can just count up k times, right, from the beginning of the list, but you can't do that from the right, because this list only goes one way, and also you don't even know the length of the list, so it's not really doable. So instead we can use 2 pointers where so first to get the left side, we can go k times to the right, and that would lead, and so, or k minus 1 times to the right, because like if it's if it's like we want the kth node from the left side, then if the kth node is like the first node from the left side is literally just the first node, you don't want to go anywhere, so it's just k minus 1, because like the second node, right, you'd go up 1 time, so it's always minus 1, and then you save that as the left node, right? So left is equal to whatever the pointer's at right now, so we'll call that pointer cur. So we're going to use cur, right? So cur is going to go here, we're going to save left there. But now to get the right side, what you can do is we're going to keep using cur. So we're going to spawn in another pointer here at head, because if you notice, the distance from the left side of the list and then the kth node from the left is going to be the exact same as the distance from the right side of the list and the kth node from the right? It's always going to be the same. So we can use that. So we can pretty much just shift. If we add a pointer at head now, because we already have cur that's here at the 2, if we iterate both of those to the very end of the list, then that same distance is going to be retained. By the very end, I mean if we iterate that until cur reaches the end of the list, so until when cur is at 5, and if we maintain that same distance, then that left pointer that started at head would be at the node that we call right, because that's k elements from the right side of the list now, right? That's the node that we're going to be at here, and then we can switch the values of those 2 nodes, because now we've found this node at the right side and the kth node from the right side, and now we can switch those values and return the list. Okay, let's code it. So first thing first, let's get the kth node from the left side. So we can pretty much get cur, right? So cur is equal to head. For I in range like k minus 1, cur is equal to cur dot next. And now cur is where we want it to be. So cur is now the k elements from the left side, So now we can save that. So left is equal to cur. But now what we want to do is we want to add this right thing, this right pointer, which is going to start ahead, because when we are shifting, because now we have cur that's placed here at the 2, and if we place another pointer at the 1, when we shift all of these, when we shift both those pointers to the end, then that what we're calling right is going to be situated exactly where we want it to be, right? K nodes from the right. That's why we're calling it that, because that's on the left side here, and it's going to be here at the 4. So that's why we're doing that. So while cur dot next, it's while cur dot next because if the loop ends while cur is true, then it'll end one past the 5 in the linked list, while cur is not none, like, right? But if it's while cur dot next, then it'll end exactly at the end of the linked list, which is what we want. Yeah. Okay, while cur dot next, cur is equal to cur dot next, and then not only that, we want to move right as well. So right is equal to right dot next, and then we're gonna swap the values of left and right. Left dot val and right dot val is equal to right dot val, left dot val. Now you can return the head of the linked list. Okay, the time complexity here is O of n, because cur is going through the entire list here, the entire linked list, and then the extra space is going to be O of 1 because we're not creating any new structures relative to the input.